Hello, welcome on C++ London Uni, Module 2, Class 3. Am I correct? Class 3. My goodness,
There's a fairly big clue behind you.
I'm starting to lose the track of the numbers. So many. My name is Tom Breza, for those who don't know me. This is Tristan, it's one of the main teachers. There is as well Invisible, Oliver, and Justin. They're just hiding when we locate them. They will reveal it. Thanks very much, everybody, for coming. So, just a couple of things for people who don't know us. C++ London Uni is completely voluntarily run project, so that's basically Tristan, me, myself, Oliver. We are basically doing this just from us. Yes, there's no sponsorship, at least not yet. We're working on gathering some corporate sponsorship to make sure this project is sustainable and can run for a very long time, and people like you can basically get some education. But if you'd like to help, how can you do it? There's a number of ways. First one, the most obvious one, because we would always love to keep the project free for our students, because we are being joined by lots of different people for different reasons, yes? Some people are better off, some people are, for example, from some challenge backgrounds. We have people who were disabled and struggle to get to the work, and they basically want to retrain. Somebody who is like in a job they don't like, they would like to get for promotion, or a million different reasons, yes? And this is the place for that kind of people. So if you'd like to help, if you know anybody, like a bigger company who's ready to pay some money, send them into my direction and to speak with them, see what can we do to make them happy, but as well help us with our project. Smaller things, if you need, we have like a bottable memory sticks. Yes, it's a bottable, it's a live USB, so you connect this to your laptop and you get a fully working Linux operating system with C Lion on it. If you don't have, let's say if you share a laptop with work, or you're not sure how to set it up, you're very welcome to get one of these from us. It costs us around £7 for the hardware. We suggest the price £15 just to support the cause. Another very, very important one, Tristan MacBook unfortunately died some time ago, and we are running a GoFundMe page for Tristan. So if you do benefit from these classes, you think they are awesome, they're cool, and you'd like to support our cause, go to our GoFundMe page, and you're very welcome to add some money so we can replace that machine. After the class, oh, that's the Oliver, speaking of devil. After the class, we're going to pub. Yes, and our way of appreciation is a good idea to buy these guys a couple of beers and maybe some hot food, so they know that they spend the evening nicely. Apart from today, yes, on Tuesday, apart from Tuesday's lectures, what you can see now, we have as well another class, which is on Thursday. It's not really a class, it's a workshop. So basically what we do is people who trained to learn today, they're going on Thursday to put in practice what they learn. This is even more important than today, because then actually you're really trying to your skills. So very important, don't miss those classes. Go to our website, check where we are. Sometimes we are in Skills Matters, so same place, but most of the time we are opposite of Skills Matters in Costa. So go there yourself, buy a drink, sit down and work with other people on exercises. If you'd like to have the most up-to-date information, follow me on Twitter. My Twitter handle is xxbms. But as well, go to our website, cpplondonuni.com. And for those who are new, how it's done about booking RSVP. If we are having a class or workshop in Skills Matters, you have to RSVP on Skills Matters website. Yes, otherwise they will not let you into the building. If the meetup is at, let's say, Mimecast or at Costa, you have to RSVP on our website. Mimecast and other places don't have a special place where to do RSVP, so we have to supply them with the list of the names. Unfortunately, I'm still awaiting for the confirmation for further classes. The Skills Matter seems to be very busy and they didn't come back to me. I was hoping to get them before start of class today, but I just sent another message to them asking whether they could confirm the booking for following weeks. So please keep an eye on our website, because as soon as I have the information, I will update. The worst case that the failover will be talking to Oliver whether he could accommodate us in Mimecast. But for now, we're just waiting. So that's all from me. So remember,
next week we're here.
Are we?
Perhaps we're not. Okay.
I don't think
Okay.
there's booked.
Well, never mind then.
I think today is the last class booked for Mimecast.
Okay. Well, ignore me. I don't know.
No, I registered for it.
Is it? Is it? So maybe they put it and they didn't tell me. I didn't look at on the
If
next.
it's there, yeah, I've registered for next week.
You did. Okay, so that means they booked it in. So that's good.
We
That's
have
it.
the 22nd, yes.
So that means they added the class. Cool.
And the 27th.
That's Thursday.
Oh.
Yeah. Oh, wait, hold on.
That's Thursday. So that's workshop.
Yeah, let's have
Well,
a-
anyway, we'll work it out.
So
Don't
keep an
have-
eye
we
on
don't
our
have next week.
website.
So just be Tuesday next week, we do not have.
Yeah.
Thursday this week we have here.
Which is the workshop.
The workshop next week on Thursday is here, but yeah, we'll have to sort out Tuesday.
Yeah. So let's
Next-
see.
next Tuesday.
I'm waiting for the Brady to update me. So that's all from me. Thank you very much, and I'm passing you to Tristan. Where is Justin?
All right. Good evening, everybody. Again, welcome back. So before we start, just one important announcement, and that is that Oliver, you may have spotted, has this ill-advised facial adornment. He claims it's for charity. It's seriously, it's Movember, obviously. Please do go to this URL and pledge a few pounds. It's for a good cause.
Yeah.
The good cause being Oliver looking silly for a month. But
Are we the money's for him to buy the
No, it all goes to charity. It all goes to charity. So please do go to that URL and give generously. All right, where were we? C++, yeah. So normal feedback slide, because I put this at the start every week, and you've all seen it now lots of times, I'm sure. But we have the Slack channel for anybody who might be new watching online. We have a Slack channel. We've got our own room in there. So if you want to join, if you want to talk to us, you can go to this URL, put in your email address, and it will send you an invitation to join, what they call an invitation, basically a link so that you can join. I mentioned this the last couple of weeks, but just to reiterate one more time, Ollie pre-Mustache recorded some live coding sessions all about test-driven development and mocking and things like that. Recorded 3 separate videos. The links are there, but they're also they're all on our YouTube channel. If you go to youtube.com/CPP London Uni, you can find those videos. They're pretty long, and some of it's pretty advanced, more advanced than we've covered in the class so far. But what I've seen of them looks pretty good, and Ollie really knows his stuff, as anybody who's been here for a while will know. So highly recommend it if you can spare a few hours to go and have a look at those. Yeah, you can play it on a higher speed, and sadly it doesn't give you a chipmunk voice, which would be even more amusing.
Funny,
Anyway, moving on. So last week, this module is all about custom types, making our own types, writing our own structs, our own data types. And last week was session 2. We talked a bit more about member functions, about separating the definitions and the declarations of member functions, just like you can with ordinary functions. We had a bit of a sidestep. We talked about function overloading. That's where you have functions with the same name but different types of parameters. which is something that C++ allows. C doesn't, but C++ does. And you can overload ordinary functions, that is non-member functions, and you can overload member functions as well. So we talked about function overloading, and then one special application of function overloading is something called operator overloading, which we started to talk about but ran out of time. So this week we're going to really start again with operator overloading, and we're going to then go on to talk about constructors and destructors. So that's on the menu for today. Last week I gave you quite a lot to do. Actually, 9 different steps to this. So who had a go at the homework? Oh, most of you. Excellent. Who was successful in, let's say, the first 6 parts? Those were the relatively easy ones. Okay, 7, 8, 9. You all managed all 9 parts. Awesome. All right, well done. The last part in particular was quite tricky because, well, first of all, we haven't really covered operator overloading, but and secondly, the use-defined literals are quite a strange thing, and I haven't said anything whatsoever about them. But so if you manage that, yeah, very well done. So we'll have a quick look at this. If you want to get this yourself, this is the URL. It's on our GitHub. This is actually a bit too huge, isn't it? I'll get it down a bit. There we are. Okay, so we have a header, conversion.hpp, and a corresponding implementation file, version.cpp. So what I asked you to do was to create a struct named meters and another named feet. Now the whole idea of this exercise was to sort of introduce you to the idea of type safety as well, about how you can create these structs to represent values of that represent a type with a particular unit, let's say. So you could write your code that uses meters to represent distance, and if somebody else writes their code and uses feet to represent distance, so you can use the type safety rules in C++ to make sure that you can't accidentally call a function that expects a distance in feet with your code that expects a distance in meters, right? The type safety rules will prevent you doing that unless you actually explicitly convert it, right? So there's a very famous case of, I think it was a Mars lander that NASA sent off to Mars intending to land on the planet, and it ended up burning up in orbit because one team that had written one part of the software used metric measurements, and the other part, another team who'd written another part of the guidance software had used feet. Right, so this is a very famous case. So you can look it up, and yeah, it ended up entering the atmosphere much too fast, burned up in orbit, or crashed into the planet. Whatever it did, it broke because the 2 teams used different units, which
Clearly they missed our class.
is kind of ridiculous. So that was what inspired this homework, that little tale, and this thing of using strong types to protect yourself from those kind of mistakes. It's also what's done in the Chrono library, part of the standard library. The Chrono types do this. So anyway, yes. So I wanted you to write a struct called meters. Here it is. This has got a little bit more than I told you to do in step 1. But anyway, struct meters, which has a double member that I've just called value. And a similar one, or in fact exactly the same, one called feet. So there we are, struct meters, double value, struct feet, double value. And then I wanted you to write a free function 2feet, which takes an argument of type meters and returns the equivalent distance in feet, and a type called 2meters that does the reverse, takes a distance in feet and returns the distance in meters.
Probably an important thing to mention as well is the forward declaration.
No, we'll get to it, Ollie. We'll get to it.
That was why you're asking me, right?
We'll get to it. You could have done these inline if you use the inline keyword, but I wrote them, put the definitions in the other file. So here's 2 feet. So I've, just to avoid putting these magic numbers in code, I've written a couple of global const variables. Const_expr is a keyword that's was introduced in C++11. Lets you specify that this is a compile time constant. In this case, it doesn't really make any difference if you just said const. It would have done exactly the same thing. But so this is the conversion factor. So 1 foot is 0.3048 meters, so a bit over 30 centimeters, and converting the other way around, it's 1 divided by that number, whatever it is. So to convert our meters to feet, we take the meters value, multiply it by this conversion factor, and encase the return in a struct feet, and we return that type. Okay, so hopefully all of you did something like m.value times 0.3048. And for converting feet to meters, we just do it the other way around. So you could either divide by 0.3048, or you can multiply by that. Mathematically, it's the same thing. So those are our conversion functions.
And I'm assuming you left it off on the second one to demonstrate.
Oh yes, yes. So yeah, well spotted. Yeah. So here I've explicitly written that we want to construct an object of type feet. Here, I just want to demonstrate, as Ollie says, that because it knows that the function return type is meters, we don't actually have to explicitly write it here. We can just put the curly braces in, and it knows, well, the return type is meters, so I want to construct an object of type meters.
Is there any preferred version?
It's just a matter of taste, really. If you're, I would say for a small function like this, where the return type's right there, you can work out what it is. If this was a big, long function that by the time, if it's a couple hundred lines, and by the time you get to the bottom, you've forgotten what the return type was, then it's better to do it explicitly. Yeah.
Why did you not pass argument as a reference?
That's a good question. So I could easily have done a const meters ref there, and that would not in any way have been wrong, because as I said before, passing by const reference should be your default way of passing arguments in C++. Here we know that both meters and feet are just wrapping a double. They've just got one member that's of type double, so they're the same size as a double. And in general, for built-in types, they're small. They're a couple of machine words, like 8 bytes a double. So they're small enough that we can pass them by value. So it's because we know that meters and feet are small, basically. That is, they don't occupy much stack space, so they can, hypothetically be passed in registers and things. So yes, if you did const meters ref there, that was perfectly fine as well. Okay, let's go back to the header. So the next thing, so that was 3 and 4. Write a member function add to struct meters, taking an argument of type meters. Update the stored distance by adding a new distance to it. So I asked you, what should the return type of this function be, and why?
I just used the void because you can access any of the time. You don't need to return anything, and you're changing the actual member variable value because you're adding to it.
Yeah. So void would be the obvious choice, and not incorrect. Like if you wanted to return void, a sneaky thing you can do is to return a reference to meters, a reference to the object that you're modifying.
But is that not dangerous?
No, because you know that the object that you're operating on an object that it has to be alive. Otherwise, you couldn't call the.
Exactly.
Otherwise, you couldn't call the member function.
So how do you call it? Sorry.
So I'll just show you the definition of it. So here's meters. So this is an out-of-line definition of a member function. So we say this is the function add that belongs to type meters. takes an argument, another object of type meters. So we're saying our value, we're going to append or plus equals m's value, m being the other object. And then we're going to return a reference to this. So this is the object we're operating on. For silly reasons, it's a pointer in C++, should be a reference really, but it's a pointer, so we have to dereference the pointer. That's what this star does. So this gives us a reference to the object we're operating on, a reference to ourselves. And you say, well, why would you do that? Why is that useful? And I can show you why it's useful by having a quick look in main. So I won't go through all the test functions because it would take a while. But what we can do here is we can have our object of type meters, and then we can add another meters, and then we can chain multiple adds. So this thing about returning a reference to yourself means that you can chain function calls here. So we're adding 1.5 meters, and then we're adding 1 foot. So that thing about returning the reference is a bit sneaky, and if you didn't get it, don't worry, because it was intended to be kind of tricky. But it's just a sort of, I don't know what you would say.
Method chaining.
So it allows method chaining. It allows you to.
So wouldn't you be able to do that anyway?
No, because if it returned void, so if it add return void, let's go back to this. So if add return void, let's look at this one. Then this expression, this function call would return void. So if I tried to call dot, if I tried to use dot on a void object, it would say no, you can't. Like void isn't a type. Well, isn't a proper type. You can't call a member function on void.
If it was any built-in type, it would not work.
Yeah, or anything that didn't have an add method.
Yeah.
Right. So that's just a little. I don't know. If that seems kind of mysterious and magical to you, don't worry about it too much. It was just kind of an added bonus, not main. This one header. So that covered this. I wanted an add function that let you add meters to meters and add feet to feet. So that covers those. And then I said I wanted 2 overloads of toString, taking meters and feet. So the standard library, I mentioned it last week, has a function called toString that converts all sorts of different types to standard string. The reason for this question was basically just to get you writing overloads. There's no more or less to it than that. I just wanted to demonstrate functions with the same name but different argument types, and also really to demonstrate this thing of strong typing that I was talking about. So where do I put them? Operator plus toString, there we are. So initially I just did this. So I called toString with a standard toString with m.value, which is a double, and then I appended m on the end for meters. This, it turns out, standard toString does a bit of a funny thing to doubles. It appends lots of needless zeros on the end, so it looks a bit messy. You can get a more nicely formatted string by using this thing called a string stream. And string stream works exactly the same as cout, but you can stream things to it. So we stream the value followed by an m character, and then string stream lets you get the string it's building. So string stream is a bit like a string builder that you would have in other languages. Right? It lets you construct a string in.
So why do you need to return it as a .str?
So because ss, this variable, has type oString, and the str method returns the string that is being built, if you see what I mean.
String.
Yeah.
Is it like .format?
Probably. I don't know.
It's not quite like .format. .format would be closer to like, well, printfing, because formatting is
Oh, I see.
format values.
Yeah.
Probably should also mention that we've used oString stream there because we just want to chuck stuff in it and then get the final string. There's a
An iString
stream
that lets you read from it as well.
There's one that lets you read from it in one direction, and there's one that's bidirectional. So this is unidirectional in that you can stick stuff in it and then get a final string out.
Right, okay.
There's another one where you have to start it off with something in it, and then you can read it into integers and whatnot.
So it's like see out what you can.
Yes, but instead of printing it all to the console,
It goes into the
it creates a string out of the things that you're streaming to
oh,
it.
brilliant.
So
Yeah.
it basically packs it up and then you can choose to print it out or return it as an actual
Or return it as
individual
a string, yeah.
C++ equivalent of printf and scanf rolled into a class.
Yeah. So yes, and toString on feet is exactly the same.
String.
The header is called stream, so it's this one here. All right, so those were the first 6, the easy ones that I sort of expected most people to be able to do, not necessarily the return type, because that was a bit of a nasty one, wasn't obvious at all. But then we got on to the slightly trickier ones. So I said write an overload of meters add, which takes an argument of type feet. That is, it allows you to add a distance in feet to your existing object of type meters.
I have a very good question.
Yeah.
Go to the explanation of that. So when I was doing the homework, I tried to the return time to be, when just doing simple stuff like say feet, right? Just adding feet.
Yeah.
So I did a return type of a reference to feet, but reference to meters as a return type.
For this one, yeah.
The C line gave me an error, so I'm not sure why it didn't. It said something about can't have a temporary variable in your scope passed as a reference or something weird error like that. And I was quite surprised because you've done it.
Okay.
That sounds like
I didn't copy and paste it, but I then just passed it as value.
if you that sounds more like something would be a warning, not an error. Although
I'd have to have a look and see what C line's trying to tell you.
Well, I don't have it anymore.
Okay.
I didn't do it.
Yeah, so I wanted you to add basically this overload of add. So this is a overload of add that takes a distance in feet and adds it to this with the appropriate conversion, of course. But this presents a bit of a problem because at this point we haven't yet defined what feet is. And you say, okay, well, we could move these around. We could define struct feet first. We could swap feet and meters in the header file. But then, I also told you to add an overload of add to struct feet. So we've just got the same problem. So flipping them around is not going to solve anything. So how do we solve this? And the answer is with this little line just here. So the trouble is when the compiler's looking, so it reads our code from top to bottom, for the most part anyway. And when it gets here, it sees this name feet, and it has no idea what that is. And so you probably got an error, something like unknown type name or something like that. So what we can do is we can use this, which is called a forward declaration. So this says that feet, the name feet represents a type. We don't know anything about it yet. We don't know how big it is. We don't know its members. We don't know its member functions. We don't know anything about it other than the name feet represents a type, right? So at this point, feet is what's called an incomplete type. We can't do very much with it, but it means that the compiler will recognize that this name represents some type that you're going to complete later. All right, so at this point, we can write the declaration of a function that takes an argument of type feet. But we can only write the declaration here. We couldn't write, if we tried to write the definition in line, that would be an error, because then we'd be trying to use the type that we haven't yet defined. So doing this requires you to write the definition out of line, requires you to write the definition separately. It's not a problem here. Here it's fine because at the point where we get to here, we've fully defined this struct meters, right? We've reached the closing brace of this struct definition, so meters is a complete type by the time we get to this member function. So that was why I said that this was tricky, because you had to do this trick with the forward declaration, which again, I get a bit mean with these homeworks. but at least I warn you that I'm being mean. So yes, you needed to forward declare it to say to the compiler, this is a type, and I'm going to tell you about it later.
Maybe we should reuse this when we teach templating, because you could solve it with templates as well.
Yeah, maybe. And then I said, implement your add member functions as overloads of operator plus equals. So I actually did this 2 different ways here. So I added 2 overloads of operator plus equals as member functions of struct meters. So that the actual implementation of these is identical to the implementation of add. But here we're defining our operators as member functions. And then just to show you that you can, I also implemented them as non-members as well. Now, we're going to spend quite a bit of time today talking about these things as members and non-members. So I just put this in the homework as an example. So if you want to, after we've discussed it in the class today, if you want to go back and have a look at this, it'll probably make more sense than if I start trying to half explain it now.
So I had difficulties with that, where I defined these 3 functions.
Yeah. Yeah, for operator plus equals, it's generally better to put them as member functions rather than free functions. But I was sort of demonstrating that it is possible to have them as non-members as well. And then finally, I say there's a further extension. This really was quite tricky, I thought, anyway, is to implement user-defined literals for meters and feet. So I put these right down at the bottom. So this is a new feature in C++11 that it's sort of implemented as operator overloading, but in a way it's messing about with the parser almost. Because what this lets you do is to write a number and put this at the end of it. So you know how normally you'd write like 1.0f, and that would say, okay, this is a floating point literal. So these are user-defined literals. This lets you put a suffix on a number and say, okay, this suffix means that that number is of type meters. And this suffix means that this value, this number you've just put in, is of type feet.
Well, it's saying the number, you want to convert the number to that type. It performs a conversion for you.
So user-defined literals must begin with an underscore. It's just one of those rules. Things without an underscore are reserved for the standard library. So I've named them underscore m and underscore ft. So I'll just briefly, oh yes, and there are only a very limited number of types of arguments that are allowed. So you're allowed long double, which is the longest floating point type that the implementation uses. You can have long unsigned int or unsigned long int if you want an integer value, and there's an overload for character arrays as well.
So that thing in the brackets is an argument.
Yeah, yes, exactly. So I'll show you what this looks like in the actual.
What about the return? Are there any limitations?
No, there's no limitation on the return type.
If we have such a long number, and we're adding only the m,
Yeah,
that's very wasteful.
There's not so much wasteful as the fact that you'll probably get a compiler warning saying you're compressing a long double into a double if they happen to be different types.
Well, static says so. Here you can see I've declared a variable called m, and so I've done 1.234 and then underscore m, and now m has type meters. So that's what this conversion operator does. This user-defined literal operator says.
So this number 1.234 is that of type long?
The raw, what they call the uncooked literal, that's this bit. That initially, when the compiler reads it, has type long double.
Okay.
And then in my conversion operator, I'm converting that to double. Right. So if I did write something with 207, not 207, many decimal places, then that would truncate it. But to be honest, you're probably never going to write a literal that has too much precision for a double, because who would?
That's the one that we saw before, was the declaration. Do we have the definition?
Yep. So definition, I'll put them right down here. So to avoid errors, we take our long double and we use this function or operator static cast to convert it to a double. So cast is a way of basically overriding the type system, saying, I know better than you, I want to force this conversion, right? So we are forcibly converting this long double into just a regular double.
Why are you doing that?
Because meters, the member type, the value member is a double. So we have to squish the long double down.
Why are you taking long double?
Sorry?
Why are you taking the long double? As
Because we have to take a long double because the language rules say we do. Right? There are only a limited number of argument types that you can use for user-defined literals, and long double is one of them.
C line was asked. That means basically it suggested I use a static cast double, but I thought that was too complicated, so I just put a double in brackets.
Yeah. So if you put double in brackets, that's a C cast, right? So
why would you do it?
So there are 5 different types of casts in C++, right? Of which C cast is the most powerful. So can't really go into all of them now, but basically you want to avoid C casts if possible. So as the name implies, they're inherited from C, and they do all sorts of conversions no matter what. There's basically no protection. If it is at all in any way possible to convert type A to type B, the C cast will somehow do it. Whereas the other 4 kinds of casts, the C++ casts, these are these ugly ones with the very long names that you put the argument in angle brackets. Strausstrup added these, and he made them deliberately ugly, right? Because if you see these in your code, it's a warning that you have to look at this quite carefully and say, oh, am I sure about this? Is this absolutely right? Because whenever you use a cast, you are, as I say, overriding the type system to an extent. Right, so the C++ casts deliberately have ugly names in order to make them stick out in the code. Because doing C-style casts, it's just a type name in brackets, and it's very easy to kind of overlook when you're just scan reading the code. Whereas static cast, reinterpret cast, const cast, and dynamic cast, which are the 4 C++ ones, they all have very long names, and they stick out like a sore thumb in your code.
So is that, I mean, the syntax there, is that similar to like vector?
The syntax is similar in that it uses these angle brackets. It's not actually a template, but it looks a bit like one. So this means take my value and statically, that is at compile time, turn it into a double. Okay, and the static compile time check means that it's going to do a check to see whether this is a legitimate conversion, right? And in this case, it's a legitimate conversion, albeit one that throws away information. So that's why we have to do this static cast, because otherwise you'd probably get a warning saying this is a narrowing conversion.
Okay. So I went a little bit further and did it with so that it would take integers, not just doubles. But I want to say, what if I wanted to have a negative, like negative meters, because it only takes an unsigned long.
Yeah. So did you try it?
I tried it. It just doesn't.
No.
work.
So this was supposed to be an extension task, so I don't want to spend too long discussing it, right? But basically, what happens is when you enter a literal negative number, that's not actually what's happening, right? So when you have an integer, the integer part is always positive, and then it applies operator minus. So it takes your type, makes it into a meters, and then it will try and apply a unary negation operator minus. So you probably didn't define that for your type meters, so that's not going to work.
So you have to do another definition on top of that. Okay.
So anyway,
just finish off. I mean, that you wouldn't. The old solution to that is to make the rest of your program long doubles, so you don't have to get into the cast. Is that what you should?
I would
just accept the cast.
I just accept the cast because you're really never going to enter a long double literal.
No, but it's forcing you to go down that route.
Depends on what you're building, I think is the real answer here, right? If precision of a double is fine for your design, then no one should be providing literals that are that long anyway.
Yeah.
If, however, you physically need it.
So if you need, A double gives you how many, like 8 digits of precision. So that's getting down to micrometers. So if you need to go into sort of nanometers, picometers, and you really need 16 decimal places, then use a long double member.
Yeah, but they don't use a long double member just because you want to use literals.
Exactly that, yes.
Yeah.
Anyway, so that was the homework. So by the sound of things, everyone got on pretty well with that, which is...
So
Oh, sorry.
I just wanted to very quickly.
It's not about user-defined literals, is it?
Well, yes, just
Oh.
very quickly. Just going to say the whole point of them is that you can quickly assign something to a class or structure.
Yes, yeah. So, for example, in the standard library, there's a user-defined literal for a string. So, if you know the string literals, just a bunch of characters in double quotes, they don't have type standard string because, for reasons, they have type array of car. Right, C array, really nasty. So the C++ standard library has this user-defined literal, it's just an S. So once you've included the right namespace, you can just write your literal and put an S on the end, and that will give you a standard string.
So you don't need to put quotations. You just
No, you do. You still put the quotations, but you put an S on the end, and rather than being a const char star or a const char array of n things, it's just a standard string for you right there.
You can make your own of those too.
Yeah.
You can do it for numbers, you can do it quoted.
So is that inside the quote or outside the
Yeah,
S?
after the quotation.
After the quotes, because otherwise it would be part of the string.
You could use the escape character.
No, although raw string literals are a fun thing in themselves. But anyway, that's not week 1's homework solution. Sorry, copy the wrong one. Week 2 homework solution. So my solution, which is not necessarily the best way of doing things, but my way of doing things, you can find it there. So I don't know why I'm trying to wipe that off the screen. That's just going mad. So yeah, you can find the code there. As I say, particularly the user-defined literal one was intended to be a bit nasty. So if you found that tricky, then sorry. But well done for those of you who did it. Whew. So any questions about the things we actually did cover last week? That is function overloading and member functions separating the definitions and the declarations. Yeah.
Can I find slides for them somewhere?
Oh yeah. Oh sorry. Are you new?
Yeah.
Oh well. Welcome. Sorry. Yeah, you've jumped in, as you can see, on week 3 of module 2. But all the slides for all the sessions are on our GitHub repository. So yeah. So if we just go back, if you just go to github.com/CPP London Uni, just this first bit, you'll see all the repositories. And then if you look for ones called course materials, so there's course materials for this module, there's course materials for the previous module, which was the introductory one. When we have a bit of a break, I'll come and make sure you can find them.
And of course, all the videos of the sessions are on YouTube.
Yes, that's the other thing. So we record all these, we broadcast them live, we're going out live on YouTube right now. And so if you want to, all the videos for all our sessions, pretty much ever, apart from we're missing the first 5 or something, but apart from that, they're all on YouTube, like a year's worth. So you can go back and watch me, or listen to me anyway, and watch the slides.
What's the name of the thing? What's the name of the channel?
So it's CPP London Uni on YouTube.
YouTube.com/CPP London Uni.
Yep. Okay. Let's go back and talk a bit more about operator overloading. We just saw a brief example of it, but we'll go into a bit more detail. So for the built-in types, ints, floats, doubles, bools, chars, etc., the language defines lots of operations on them. So we can compare 2 bools for equality. both true, they're both false, they're different. We can compare balls for equality. We can negate an int. So if you have a variable, an int of type I, you can type -I, and it will take your int. And so if I was 3, then -I will give you -3. Right? If I was -3, then -I will give you +3. Right, so we write these as A equals B, or this is the unary negation operator, so you just write -I. And in these cases, equals and minus, they're examples of what are called operators. Right, so they're sort of things that are built into the language that we can do to the built-in types. Right, these are built-in operators. And we have some operators that take 2 arguments. So for example, the equality operator here takes 2 arguments. So it's what we call a binary operator. Binary 2, we have A and B, 2 arguments. It's a binary operator. We can also have unary operators. So here we're using the minus as a unary operator. We have unary operators, we have binary operators. And then we have some funny things, some funny operators that have both unary and binary forms. So plus and minus and star, although star is a bit weird, these have both unary and binary forms, because we can write -I to just negate an int, but we can also write I minus j, right, to subtract 2 integers from each other. So minus has both a unary form, like this, and it has a binary form. We have binary operators, we have unary operators. There's also the function call operator, which is neither of those, but that's a complication we don't have to worry about right now.
That was plus or minus to incremental.
Sorry?
That was plus or minus to decremental.
By 1, yeah.
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 So
For an int, yeah. So you can call ++I or I++.
Yeah.
Yes, that's a unary operator.
Oh, okay.
Yeah, because it just operates on one object.
Yeah, but here you've just done -I.
Yes, so -I just reverses the sign of an integer.
It doesn't change I.
Oh.
Yeah.
It's a new value that's a negative of I.
A mathematical operation.
Yeah. So these operators are defined for all the built-in types. And that's part of the language. Just as the types are built in, the operations on them are built in. But I said before, a lot of the goals of C++, especially in the early days, were to allow you to write user-defined types that were as good as on a first-class basis along with built-in types. To write your own types that were usable in every way that a built-in type is usable. This is something that you can't do in C, but it was one of the goals of C++. Still is one of the goals of C++ in many ways. So we can implement operators, all of these operators that are defined on the built-in types, almost all of them, we can define what those operators mean for our custom types as well. So for example, we've just seen we can compare 2 balls for equality, compare 2 doubles for equality, compare 2 ints for equality. We could define what the equality operator means for our point type. So last week I had several examples with this point struct that just had 2 members, x and y. So we can have a reasonably good idea of what it means for 2 points to be the same. And in fact, we did write member functions equal to and not equal to. So this process is called operator overloading, because we're adding new meanings to the operator. We're overloading the meaning of the operator. Right? So it's already defined for ints and floats and doubles and all the rest. That's built in part of the language. And we can define what it means for our own types as well. And this is done all over the place in the standard library. So it means that you can use, it's one of the reasons really that C++ doesn't have a built-in string type, unlike many other languages, because we have all this things like operator overloading that let you write a string type as a library type rather than as something that has to be built in. And you can still say, are these two strings the same? Do they have the same characters? Right? You can say, is this string less than this other string? Right? And there are reasonable definitions of what it means for one string to be less than another. So this operator overloading, not every language lets you do it. C doesn't let you do it. Java, I don't think, lets you do it. But C++ does. Not everybody likes it, but I do. I think it's great that you can just use the natural operations on types. You know, I can write I could have an infinite precision float that I can just add like a real float, an infinite precision floating point type that I can manipulate like the built-in floating point types, for example. Or I can write a matrix library that lets me do matrix multiplication just using the times operator. I can do matrix plus vector, or matrix times vector, or vector plus vector, or whatever. You can write a linear algebra library that lets you write equations that look like equations, or at least look fairly similar. So this operator overloading is really powerful. And as with everything, it can be misused. So don't misuse it. If it hurts, don't do it, as Björn Strausrup likes to say in his talks. So how do we write these overloads? Well, you've already seen it, and those of you who did the homework will have already had a go at this. But we write a function that's called operator something, where that @ sign is a placeholder, represents the operator we want to overload. So for example, we wanted to overload the equality operator, equals equals. We'd write a function named operator equals equals. I'm using @ as a placeholder because you can't use star, because star actually means something, right? So @ there is just a placeholder. So we'd write operator equals equals, for example, or operator exclamation mark equals, or what have you. So here's an example of how we write a declaration of the equality operator for 2 points. Take a reference to a point P, a reference to a point Q. And once the compiler has seen this declaration, we can, in our source code, just write P equals equals Q. And when the compiler sees that, it goes, okay, I know how to apply this operator to my points. And so the thing on the left becomes the first argument, and the thing on the right becomes the second argument. And then it returns the Boolean value. Obviously, bool would be the right return type here, because that's what you would expect your equality operator to return.
Question. You have const. Could you use const expert there?
No. Const expert can't be used for function parameters.
That's a free operator.
So this is defined as a free function, yes. So once we've defined this operator, we can compare our points just like we can with built-in types. So here I've declared 2 points, P and Q, that happen to be the same. X is Y, X is 3, Y is 4. And we can assert that P equals equals Q. So this is great, I think. So almost all the operators in C++ can be overloaded. All right, I mentioned this last week. To reiterate, plus, minus, times, or star, divide by, modulus, I always forget what that one is. XOR, bitwise and bitwise OR. I'm not going to name them all. But there are lots and lots, including newer delete, which technically, according to the language rules, are operators. Please don't ever overload them, but theoretically you can do it.
So you could define the new way, let's say, if you want to overload new, how you get to the, let's say, memory space.
Yeah, exactly. That's exactly what it does, but it's generally a bad idea to do. So.
What's the one before you?
This one. Oh god, it's member function pointer dereference and select. I can't remember because it's okay. There are some operators that are very common to overload, right? So equality, inequality, the relational operators less than, greater than, etc., which don't appear to be on the list, weirdly. Anyway, less than, greater than equals, less than equals. Those are very common. This thing, the assignment operator, very common to overload. And the mathematical ones, plus, minus, times, divide, they're all very common. There are some that are just completely obscure, like this one, or that one, or one that's, please don't ever do it, but you can overload the comma operator. I have no idea why it was seen as a good idea to do, but yeah.
So this you could be writing two chars and then you could do comma and then try to do something.
Not a char, because that's a built-in type. So you can't overload the meaning, can't overload operators for you can't overload operators for built-in types.
Oh.
Right, because that's already, as I say, built into the land.
User-defined.
Only for user-defined types, yeah.
Oh, that's a good way to.
Yeah. So you can't redefine what it means to add two ints. Right? If you have two ints I and j and you do I plus j, that's always going to do integer addition.
Change that? Just the desired behavior would be to add them.
Well, you couldn't. You can't change the meaning.
No,
of
I'm
what.
just saying it wouldn't make sense.
Well, it wouldn't make
Add
sense anyway.
One, you expect two, it's already built in.
Exactly. So
That's not fun.
Break my code.
Yeah.
So for most of the operators, you have the choice whether you do them as member functions or as non-member functions. There are a few of them. For example, this guy, the array access operator. This guy, the function call operator. This guy, the member pointer access operator. Those you can only do as member functions. Assignment as well. But for most of them, you can either write them as members or as non-members.
So is this how they've written this brain fact?
No, but it does do that to your brain sometimes, because operator overloading opens the door to doing many crazy things, right? Because do you notice how on the previous slide I wrote bool operator equals point and point? That's a sensible way of writing the equality operator. You're comparing two things of the same type and you're returning a bool. But the language doesn't require you to be sensible. You can compare any two types you like, or you can write an operator overload for any two types you like, as long as they're not both built-in types. As long as at least one of them is a user-defined type, you can write an operator overload for any two types you like. And this is the worst thing about it, you can return any type you like. Right? There's no requirement that your operator equals overload returns a bool, which is really silly. So operator overloading, it opens the door to doing crazy things. Right? There's a saying that, what is it, that C allows you to shoot yourself in the foot. C++ makes it harder, but when you do, it takes off your whole leg. Right. So the golden rule with operator overloading, the absolute golden rule is only implement operator overloads when there's a natural meaning to that operator. Right? Do as the ints do. So if you are overloading operator plus, then that should have something, if you're going to input, you should only overload that for types where it makes sense to have some notion of addition, right? And please make it return a new object that is those things added together, right? If you're comparing two things, if you're overloading operator equals, make it return a bool and make it return true if they're the same value and false if they're different values, right? Don't launch the missiles if somebody says P equals Q. You can, right? There's nothing stopping you. Or at least there are no language rules stopping you. But your co-workers at code review might, punch you.
Could you overload the assignment operator in the copy assignment?
The assignment operator.
Okay, so you can overload the assignment operator for types, and that defines what happens when you do, like, for two existing variables, you do A equals B, right? And that's actually quite a special operator overload in that you get it, it's literally called a special member function, and you get it for your types. You get an overload of operator equals, even if you don't specifically write one. So yes, you can, and we will somewhere down the road cover that, but not today. Do as the ints do. Golden rule. Be sensible, right? This is an extremely powerful tool. It's like running with scissors or whatever. Scissors are very, very useful things. Can be quite dangerous. Be sensible with them. So I just mentioned this. Most of the operators, you can write the overloads either as member functions or as non-member functions. And a few of them can only be implemented, can only be member functions. You have to look up on CPP reference exactly which ones those are. When we write them as non-members, binary operators take two parameters. We just saw that with the equality for points, right? You're comparing two things for equality, so the overload takes two parameters. The free function overload takes two parameters representing the left and the right of the equal sign. And a unary operator, if we write it as a free function, it takes one argument, which is the thing that we're operating on, right? If we write them as member functions, then one of the parameters is assumed for us. That's the object we're operating on. Right? That's this. So if we were to write operator equals as a member, then the left-hand side, so then it would call operator equals, so you'd say A equals B, and that would call the operator equals on A. And that would have a single argument, which would be passed as B. And for unary operators, the member version would have 0 parameters. If you get this wrong, the compiler is going to bark at you, right? So don't worry about it too much. I said that the return type, the language has no restrictions on the return type, but it does have restrictions on the number of parameters. So if you get this wrong, the compiler will get cross with you. But we can put these things as a table. Instead, we have unary operators and binary operators. So if we write them as non-members, the unary operators have 1 parameter, the binary operators have 2. So this is what you'd expect. It's a little more tricky when we define these things as member functions. We basically just reduce it by 1. The left-hand side for a binary operator is assumed. That's this. And for unary operators, if we write them as members, then this is the thing we're operating on. So there is one particularly useful application of operator overloading, and that is to be able to print out our own types. So you've done it lots and lots of times now, printing things with standard cout. So cout is something called an output stream or an O stream, and that has an overload of the bit shift operator, the chevron, right? Left angle bracket, 2 left angle brackets, less than, right? It has an overload of that operator. So the cout streaming function, printing things in C++, is using operator overloading behind the scenes, which obviously I didn't tell you in week 1 because you'd all run away screaming. But so that uses operator overloading, and we can write an overload of the bit shift operator, the left-left streaming operator for our own types in order to implement streaming to cout. So this is really useful for debugging. You know, we can print our own types just like we can print floats and doubles and strings. So string has an overload of the streaming operator. This must be written as a non-member function. So I've said most operator overloads, you have the option of whether you write it as a member or non-member. And in fact, the bit shift operator, which is the operator that this uses, that, in fact, in theory, you can write it as either a member or a non-member. But for output streaming, we need to write it as a non-member function. So can anybody tell me why that is? I'll show you an example of what it looks like. So this is how we define the output streaming operator for our points that we can use as an example. This is the declaration of it anyway.
Because we have 2 arguments, OStream and our argument.
Right.
Is it a member function of an output stream?
Exactly the right answer. Yes, well done. Yeah. If we wanted to write this as a member function, then it would be, we'd have to write it as a member function of the OStream class, right? Which obviously we can't do. We can't go and modify this standard library class to add a new overload. So we have to write it as a free function instead, right? So when it's a member function, it's the left-hand side. If you think about how you write this, so for some point P, we'd write this, and this would call. So it would either call the free function version, or it would try and do so when it sees this, it tries both of these alternatives, right? It tries, because this is a binary operator, it's going to try either the free function version, or it's going to try finding a member named operator left shift in this class, or whatever the type of that is. Right. So the only way we could write this as a member function would be to put it as a member of standard OStream, which obviously we can't do. We can't modify the standard library, and it would not be practical to do this for all of our own types, even if we could. So in this case, we can't do that, and we have to do that. So this is a very, very, very common thing to do. It's really helpful for debugging purposes and other things to be able to just quickly put in a print statement and kind of see what your code is doing. Printf debugging, as they call it. Well, in C++, we can provide an overload of the left shift operator, which always takes a reference to an OStream as its first argument and your type as the second argument. And it must always return an OStream reference as well. So it always returns the first argument. Why? It's to allow that chaining that I showed you in the homework solution. So if I've got a board eraser somewhere.
So is it a good rule then, if you're overloading operators to always return a reference?
No, not all of them. So for example, the equality operator, returning a bool is what you want to do. But for some of them, you want to allow chaining. So basically the compound assignment operators, so plus equals, minus equals, those you'll often want to chain. Right? So I plus equals 3, plus equals 4, plus equals whatever. Right? So the compound assignment ones and this streaming one is another, because you can imagine we could do cout and then our type and then whatever. We'll put a string literal in there. Right, and what will happen is when it does this, it will first evaluate this. Well, this is going to return an O-stream reference. And then it's going to say, okay, well, I've got this thing on the left that's an O-stream reference, and this operator, and this thing on the right. So it's going to look for another overload of the left shift operator, taking as its first argument an O-stream, and its second argument, in this case, a string literal.
Okay, but generally then, the compound one is a good idea.
For the compound ones, yeah, if you want to allow chaining.
Yeah, it's just that I just naturally went to void in the homework, so I missed that one. So I just want to get in my mind that if I'm doing the overloading with the stuff that can be chained,
It's a good idea. So this is how you would, or is an example of how you might write the output stream operator for a point. So we take our O stream, our output stream, and then we pass. So for a point, I've just done the x and y in round brackets with a comma in the middle. Right, so this streams an open bracket, the x value, comma and a space, the y value, and a closing bracket. All right, and then we return the O stream that we were given to allow the chain up. So if you want to know how to print your own types, this is it. This is just look at that, memorize it. Yeah.
What's that P there stand for?
Oh, P, a point. Yeah.
Yeah, the point thing he's got there on the slide.
There you go.
Should also point out that member function operator overloads preferred over 3.
And they're not. They go into overload resolution.
Oh, shit, of course.
So this is an alternative of defining a print function within our struct.
Well, you may well have a print function in your struct that does the output stream, but this will allow everybody to just print one of your types by, as we've seen, we build up these long chains of output streams, and it lets you just put a user-defined type into one of these long chains. Right now, I'll be honest, the way that C++ does printing like this is kind of ugly and kind of horrible. And I can't defend it in any way. But fortunately, C++ 20 looks like we're going to be able to get rid of this. Right? We're going to be able to have just a standard print function like normal sensible languages do. But that's for the future. But hopefully this IO stream's horribleness is going to go away. But for now, this is still a useful thing to do, and it probably will remain a useful thing to do for many years, because this is going to stick around, old code always does. So this is the technique you use for printing things, and once we've written this function, now we can just stream our point, here I've said 1, 2, and as I said, returning the reference to the O stream allows the chaining up, so we can chain up and put a new line character in there as well.
To clarify what I meant, sorry, if you have two operator overloads, which one member, one non-member, and they take exactly the same, essentially the same arguments. So one takes. So imagine you could put this as a member function, then it would prefer the member function.
Really? Oh, okay.
Could you pass multiple user-defined types into that last function?
Yeah. So if all of your types have one of these overloads, then absolutely can. Yeah. So you could have a point, a line, whatever else you have, a plane, a matrix, whatever it is, as long as it's got one of these overloads, one of these streaming overloads, then yeah, of course you can chain them all together. It's no problem.
Yeah, the key point what I was getting at was that if I make a class and I have a member function operator overload, someone cannot come along and do a free function that matches it and make code start using theirs. It will go to mine, one in mine in my constructor class.
Will it give you a warning or an error?
Depends on the compiler. I don't know, I haven't tried it.
Could you break that precedent?
You can break it.
Could you go the other way around? Could you force it to go the other way around?
No, I mean you can do an explicit call to that free function operator. You can invoke the free function operator, like colon operator, blah blah. Then you're explicitly choosing it. But anyone who's got their own code that just uses it through the normal, say, class and then doing the whole thing, which you wouldn't. No, you're not going to make them break.
So it will go always to the member overload.
Yes, unless you explicitly break the whole thing for the free function.
So, last week we had many examples that use this point. That was our point there. So I left you with this question last week. Which operators does it make sense to overload for this point struct here? So this represents a 2D point, like perhaps a pixel on a screen or something. Perhaps a coordinate on a map. Which operators does it make sense to overload? Remember the golden rule was, what was the golden rule?
Does it make sense?
Do what the ints do, right? Add.
That's because it's a vector.
It's effectively a 2D vector. Yeah, so adding 2 points, I would say that makes sense. Yeah.
All mathematical.
Sorry?
Maths. All doing the maths to the point.
So you're saying all the mathematical operators. Okay. So you say minus.
Yeah.
I say you're right. I reckon it makes logical sense to subtract 1 point from another. Go on. Sorry.
Does that make sense? Could you just not negate the x and the y and just add them?
Yes, so you could have the unary minus operator as well. That's another one that would make sense. You're saying all the maths operators. I don't think I go that far. I don't think it necessarily makes sense to multiply 2 points together. Right? To say, so what does it mean to multiply 3/2 by 9/8? Right? That's if this was a complex number, then yeah, complex multiplication is well defined. That probably so. I would say no, don't do all the mathematical operators, but addition and subtraction would be okay. Any other suggestions for operators we could overload for point?
Assignment.
We could, but we don't have to. The default assignment operator is going to be perfectly good.
It is a dot operator for vectors, but that would actually be return the single values.
No dot operator.
No, the dot operator just lets you access members, right? So you can't overload the dot operator.
No, the dot and cross product.
Oh, dot
Yeah,
and
yeah,
dot and
Ah,
cross
okay.
product. Oh, in theory you could, but that I would say is not an obvious use of. So obviously you can't overload the dot because that has to be used for members. You could perhaps use star, but I would say that's not an obvious use of operator overload.
I think they're vector
Yeah.
calculations rather than.
Well,
Yeah,
that's-
it's a little.
Yeah, the dot product and the cross product. Yeah.
I think that actually poses what the problem with what the design thing we're going for. Is it relevant for what you can use it for?
Exactly, yeah. There's one that I actually put an example up that nobody's mentioned yet, but equality and inequality is probably actually the most important, right? We can very definitely say, are these 2 points the same? Are these 2 points different? So we've got addition and subtraction, equality. We've got equality. Does it, what about less than, greater than equals, less than equals? Okay, what does it mean for 1 point to be less than another?
a bit tricky.
Yeah, exactly. Yeah, I would say that ordering, that is less than, greater than, etc. I would say that that probably doesn't make sense for a point. So complex numbers, for example, in mathematics, which can, depending on how you look at it, represent a point on a 2D plane, they don't have, there's no ordering of complex numbers, right? Because if I have a point up here and a point down there, well, is that point greater than that point? Well, if you look at the x values first, I suppose it is, but if you look at the y values first, then it's not. So I would say ordering, probably not. Yeah, did you have a suggestion? No. Saw a hand up over there.
Could you do ordering for just the x or just the y? Like, you wanted to figure out
You could do something.
length.
There are a variety of things you could do, right? And this is where you're beginning to see, like, operator overloading. Your eyes light up. You go, I can do some really clever stuff here, right? And you can, right? Operator overloading lets you do really clever things. You could define operator star for 2 points to give you the cross product, the vector cross product, which you can't for 2D vectors. But anyway, hypothetically, right? You can do all these things, but what you've got to ask yourself is, if somebody else is reading my code, is it obvious to them what this is doing?
Make evil.
Right, so I would say if they see point P and point Q, and they see P plus Q, it's going to be pretty obvious what P plus Q is going to do. Right? If they see P times Q, well, that's not obvious. Right? If they see is P equals Q, that's obvious. Is P less than Q? That's not obvious, because as we can see, there are at least 2 different ways that you could define it. Right? So in those cases, it will be better to have a named function that you can see there in the source code when you're reading it. Okay, compare by x or whatever. Right, a named function.
Wouldn't the spaceship operator, the three-way comparison, be a way so that you could nicely represent the inequalities?
I don't know enough about that.
There's partial, because you have partial ordering in that, because you can say that if x and y are both in one instance are greater than x and y in another, that's obviously greater.
You could do a lexicographical comparison, but I would say that's not obvious for a point class.
Yeah,
right?
three-way comparison gives you a way to give a different type if it's not.
So you could. So if I had named this vec2 instead of points, then we said this represents a mathematical 2D vector, then scalar multiplication would be an expected operation on an element of the vector space. In fact, that's one of the definitions of an element of the vector space, that you can do scalar multiplication. So scalar multiplication would be fine in that case. Because I called this point and we're just saying, okay, this is like, I don't know, a coordinate on a map. Scalar multiplication, yeah, it may make sense. That might be a valid thing to do. Depends on the use case.
So that's where you need good commented code or some sort of thing to know to say what's happening.
Yeah, but so the whole thing I'm trying to, this little exercise, the whole thing I'm trying to get at is that really be very limited. Rein yourself in when it comes to operator overloading. It's extremely tempting to try and be really, really clever, right? But I can't remember who said it, but there's a famous thing that if you're as clever as you can possibly be when you write your code, how the hell are you ever going to debug it, right? So rein yourself in with operator overloading. Only overload those operators that make sense. Otherwise, use named functions, which makes it clear what you're doing. And then later on, maybe you can go back and say, well, okay, perhaps it would make sense to add this operator. But I reckon, this is my thinking anyway, equality comparison very definitely. Right? I think addition and subtraction of 2 points. So plus and minus, and then these compound assignment operators, plus equals, minus equals. We had a suggestion of the unary negation as well. And there's also a unary plus, which is not very useful, but you can do it. And there's one other one that nobody has mentioned that I think would be very useful operator overload for our struct point? Output, yeah, absolutely. Who was that? Yes, output streaming operator. Yeah, so the one that was just on the last slide. Streaming to OStream, I think, would be pretty useful. And probably nothing else. At least not initially. Perhaps as we develop our code, there are other uses that we can find that would make our code clearer, make it more obvious what's going on. So, having decided what operators we're going to overload, what operators we're going to give to our point class, let's go ahead and do it. So, we've got a slightly different setup. In fact, this is recycling an exercise from the last course. Well, I wrote it, so I may as well do it again. So, if you go to this URL, so this is just what it gives you. I know it's really ugly, but sorry. But if you go to that URL, you're logged into GitHub, you'll be able to clone the starter repository. And this contains just some starter code rather than getting you to write everything from scratch. It's got a point, and I've already given you an implementation of the equality operator. So if you have trouble with this classroom link, let me know. You may have already done this one, John.
Oh, okay. Shouldn't give me a 404.
Oh no, hopefully not. Maybe I've copied the URL wrong. Just let me make sure it's.
Time for some tea. Oh, okay.
Oh no, it's yeah. The link looks fine to me. So just make sure you've typed it correctly. So lower X, capital H, lower V, Z, Q, capital H, capital X, lower A. I might just actually put the link in this Slack channel. Might make it easier.
Good idea. Pop it on the YouTube as well. Or I can do it actually.
Yeah, I'm not logged into YouTube. Okay, so I'll put the link on Slack for anybody who's logged into that.
Who does use the Slack here? Who is on the Slack? Me. Got two of you.
Yeah, no worries. Thank you for coming. Sorry, you've jumped in. As we're.
At first, then.
Yeah, no, I absolutely.
I didn't realise that this was. I thought this was just the beginning of the course.
Oh no. Well, that's fine. So sorry it's just gone way over your head. But, yeah. So as I say, we've got all our resources. All our resources, full videos, everything are online.
Yeah.
So yeah, by all means, have a look at those. If you want to come back, then you're more than welcome to do so. Otherwise, we sort of roll these around, so in a few months' time we'll be starting from scratch again.
Oh, okay,
so
cool.
if you go to our website and you can sort of see your email in there, and then we can email you when we're starting again and let you know sometime in the new year.
Oh yeah, sure. I think just because in the third lesson I didn't join that at such a late time, I can quickly go back and consume all the previous material for the day. So
Thanks for coming along today. Cheers. 7 more notifications. Have I linked to the wrong assignment?
No, it's fine. It's fine. I'm just trying to find it in our listen.
There are already lots of repositories on it.
Oh, you recycle it?
Yes.
Yeah, okay, that's one point. Yeah, that's okay. I hope that people are wanting to separate you, so I assume it's the same model. well, those of you who are working on it, since we recycled this exercise from months ago, let us know your GitHub username and we can do a review for you. Or just call me over, or Tristan.
Yeah.
Okay. So do you have a GitHub account?
Yeah.
Yeah. So just log into your GitHub account.
It's all up and up. So you've done a free month of that?
Yeah.
Yeah, that's fine. So did he give you that?
Yeah, he gave one of them.
And you've done
Yeah, I think one of them.
you could just return the invoice or go through to us.
Oh yes, of course.
Okay.
You said it was tea time.
Yes.
Tea time.
We're drinking coffee today. Yeah, that's not actually free. Once you visit the link and hit the button, you automatically get it cloned for you. So that is yours now.
Excellent.
So you can just check it out as you normally would when you have your own GitHub.
I have no idea what you're talking about. Yes.
Oh yeah, it is GitHub. So we want to clone it locally. You want to clone it to your laptop from there.
Yeah.
So if you go back to the root, clone and download. It gives you a link. So probably the the best way is to clone it for C line. C line can literally clone stuff
So
for you.
plugging into C line.
Part is built in.
Well,
So,
okay,
okay, you turned it on.
well, it is now.
Get a file.
Yes.
Not expecting.
Sure. With these operations.
Just try new project.
Okay. So operator plus equals. So when you have you done operator plus and minus? Okay, so it's easy to do them in the order that they're.
Oh yeah, of course. You need to use.
Well,
check out.
you may or may not, but it's easier to do. They get progressively more difficult. So if you've done you've done not equals, yeah, that's right. So then you want to do plus and minus. So in fact, you're almost right there. What you need to do
Copy this.
is
Yeah.
character.
You can log into GitHub as well.
That one. And now, you're absolutely right. You can do the same there. Just delete the. Yeah. And now.
Cool. Thank you. That's good. You can put it in different folders.
You've done this before.
I know, but I can't remember.
All right. So have you gone to that? Is this the URL?
Yeah.
Okay. So it will have checked out. This is yours, is it?
Clones that see you in a
Did it, and
local
it said
area
it allowed me to
that they want to do. And then you can push stuff up.
Okay. So I guess what I was assuming people would do would be to clone that on their own machine.
Just replace this with it.
So if you
Have a new
just
window
go to
for the project. And then
so then you can
you
clone
can use
or
this stuff to
download.
push it back when you're done if you want us to review it.
Do you know
Or
you
you can share it on that side.
use Git? Okay, so you can just you can download the zip file which will have most of
Download
it.
it too. Yeah, well, there's a unary operator minus. And there's a unary operative. What did you want to do? But he said that's his binary, so don't worry about those. So you want one that takes two.
Just be able to open this.
The idea is there's obviously you can have a plus to make a negative positive.
Yeah.
There's a minus to make a positive negative, or a negative positive.
That's why I was read and couldn't find.
Well, actually, you'll download it. Alright, then your downloads folder. Somewhere in there there'll be a folder.
So you're doing operator plus the next one.
So
So they
just
could you use it as a member function?
Yes.
okay. So it's just
So then this x plus equals upper x, this y equals upper y. Yeah, and then we need to return a reference to ourselves. This is a pointer to ourselves.
But this doesn't look like this.
project
Yeah,
files.
it's something to see.
So, reference this.
This is the starter codes.
The right
that.
what is it?
Easier than doing it on the website.
I don't know, start,
So do I just put my
start, this.
funds and signatures in it?
Get the objective of this points to our
I've
instance.
asked you to first of all do the
It's not
inequality one.
reference, it's the pointer to our instance. So you now
Oh,
dereference it to return reference to ourselves. Very confusing.
I know.
Well, there you go. I'll stand on it.
Just so I don't know.
Basically, this really should have been reference all along, but the concept of references didn't exist when this was invented, so it has to be pointer instead. And we're stuck with it.
So with this, we could find. Okay, then we're gonna, let's put this and
Yeah.
we're gonna try. Cool, so this is like, just.
This is where you get
That's good start.
This is something. Just trying to.
Do you use
That's fine.
Yeah.
Yeah, but I was trying to. I think.
You're using round
Yeah,
round braces to yourself.
I was using curly braces.
Oh, yeah, that's your returning a point reference.
Yeah, because it could want to change.
Not the plus operator. So the plus operator should return a new point. So that's what you must do. Plus equals modifies
Okay, right,
plus equals is the one you
okay,
must
right.
Yeah, so they're member functions. So go to the web page. They are constants. So you see, the first problem is that if they're operator plus, they should return a new object. So it should return a reference to itself.
Oh, sorry.
So, but then it also needs to be usable when you have a const instance, which is not, because that's only available. Yeah, it's still won't fix it. So you need to put constant. No, it's just it's saying that you can use these functions when you have an immutable point. When you have a constant point. So now you're allowed to use them. So it's part of yeah, and then
Sorry.
You can do it all online. You can just return those braces.
Have you written the? Have you? Okay. No, you can do p4.x.
Plus equal.
And then we'll print that and print the x value. Okay. So p2 is equal to p1, so that should give you 2. Adding p1 and p2. P2 is equal to 2.
It should work. I'm not doing anything that's really reasonable.
Yeah. So the
what's your area? What version of C++ did you specify?
The project should have 14.
Yeah, no, he's Xcode. I don't think he's not using the CMake. You can actually generate a CMake list. You can generate an Xcode project with CMake. It's probably better to do that than it will, or it might be you'll perhaps download CMake. Yeah.
So that's probably the easiest way of doing it. Well, to be honest, the Slack is a fine way to do it because I'm logged into Slack all the time. So if you want to, you can just put at someone using TC Ripple on it, just at TC Ripple. Do you code completed every day? No. That's a long way. Thank you.
You just that was all. That was just
Yeah, I know. I think it's kind of like, yeah, kind of benefit from more general thoughts like yours. I mean, you gave a tale, but the concept was quite genuinely difficult to.
Well, that actually only sort of occurred to me as I was writing it. Well, actually, there's a good point to make in code context, but even if you never really intend to use the compile time result, because you can do static testing.
Yeah, I mean, is there a balance to talk about the compile time without really needing stuff to happen?
yeah,
No, it's absolutely the operator assignment.
Oh, okay, which one? The plus C?
Yeah, right.
Yeah, right. You want to return the point.
Yeah, so there's the output code. Do what?
Return a reference.
What am I doing?
Okay, so have you done plus and just basic plus and minus? So, okay, so first of all, let's see your point struct. So we need to, let's just do a program. We'll do plus equals, minus equals upwards. So plus and minus, there are two ways to write them. Either you can do them as a binary operator, it's like A plus B, or you can just do them as a unary operator. So like I showed the examples, we just do like minus A, that's going to negate your value. So what you're doing here is you're declaring a unary version. So these are three functions. So it's got one argument, so this is like the unary version. So what you want to do is binary, so we need to put two arguments. So we can just copy this. Not very good. Not very good.
Sorry, actually points to that. Points to the left hand side, points to the right hand side.
They're both binary operators. So plus and minus.
That's right. Free operator. Free
change. So
rather than member.
Doesn't matter. I've used free. I think
they're cheats.
So now instead of this, we're not in a member function, we're in a free function.
The thing about free one is you can an operator on different times.
Yeah.
Rather than having to rely on doing operations only on that specific instance of that type.
Well,
Yeah.
You can test something supposed to be kind of point.
And then you come from Java, right?
And we don't need
So in C++, we don't need to.
If statement.
There is a new keyword. We just return. It's like the built-in types in Java, right? So this class types are generally yeah.
Yeah, it's
Okay, so what this is saying is now I've got a non-member function, operator plus. It takes it's a binary operator, so we've got the left-hand side of the plus, and right-hand side of the plus, and we're returning a new point.
Yeah.
So C++, we don't need a new keyword. You are going to have to use, actually, I hope to talk about it today, but not at times. Use the curly braces instead of the brackets.
Oh yeah, of course. We said that last week. We need to return to nice function.
semicolon on it as well.
I just forgot to include the STD in some of those. Yeah, always bloody do that.
Because
Well, let's go and have a look.
I think it's pronounced the same way.
So that actually makes sense.
Okay, so your definition of your not equal function. Oh, no, wait. Of course, P1 is not equal. Sorry. P1 is equal. P1 is equal. So they're not equal assertion. Try and just change your P2 to P3. You can see P1 and P2 are the same, so P1 and P3 are the same. Okay, so now you need to write a little test for your plus and minus. You need yes. Just notice that so O stream is derived. O stream for the work all the file stream.
So you got to.
I know you add X's and Y's and that.
Yeah.
How did you put them into a point first and then pass the point, return a point?
You can do that, but I just put it like you're going to do it on one line.
Oh, more validating, returning a reference. Because you're adding two const objects, you can't return a reference to them. Because what are you going to return a reference to? What are you going to legally return a reference to? If you had a point inside it, you declare a point inside the function, it's dead when you return a reference to a dead object.
I think that's why the C line is being
Probably a warning, not an error. That's not, you can legally do it.
Oh, okay.
Then you must have warnings as errors,
So
but legally it
what
will
we
be
need to do-
fine, but it's obviously going to crash horribly.
So what's this is saying
Is that
so
like a
P1 plus P3.
No, it's because the
P1 plus P3 returns
unfortunate. So the scope
and then you say
inherited the sound.
So yes, we have a like
C says a function says it returns something. It can still be compiled even if it doesn't actually return.
Yeah, the error message is quite misleading, though, isn't it? Yeah, doesn't not very helpful.
If you drop your return statement and don't return anything, you can call it. It won't return anything, and you can crash. And you don't. But you do fortunately get a warning from the compiler where it goes, well, you should probably do something about it. But it's just a warning.
Oh, okay. Because in some rare instances, you probably definitely want to do it.
The only time you would do it when you're doing something mental like inline assembler. So if you're doing like actual CPU instruction that's inside a function body, it's going to essentially populate the CPU register, which will result in obviously down the statement because you just put it in the AX. But that's going to be very hacky stuff. And just
I can't imagine doing that. Not at this stage.
Even when I've had to do inline assembler for specific purposes, I usually make them notations. I adhere to calling conventions, and so I actually use them normally from C++. I just get a little tip.
put the whole assertion statement in bracket. You want another
Do I need
paragraph.
to create an internal point to the side?
Yeah, one there and one
I usually use curly braces and do the math.
One like this. Do you have Visual Studio? Yeah. So then it'll just have this everything, it'll pass to this point, which will then pass
Yeah,
to
I'd love to try and explain
Yeah, it's creating the result by values when someone calls up brace. When you call brace plus.
LHS
dot brackets. Two sets of brackets.
X
Was that a
plus
correct definition?
Yeah, so your assertion is passed. So P1 plus P3.
But then how do I do this?
Yeah, perfect.
Yeah. It's like you're calling the constructor, where you are literally calling the constructor.
But how does it know that?
Because it just It looks at the return type and it goes, oh, right, so this must be a point because that's what you said you return.
Sorry, I'm really.
So I just wait. You were trying to do it before.
Trying to do something and then see
But that was
faster.
yeah.
It's more, it's
Yeah.
small.
Okay, guys, we've got about 25 minutes left. So I was going to go on to talk about, we'll start to talk about constructors and destructors, constructors in particular. We're not going to get through all of that today, but I can either, well, basically it's your choice. I can either just leave you doing this for the next 25 minutes and help you out, or we can go on, we can complete this over the course of the week, and we can go on to start talking about the new stuff. So it's really up to you what you want to do. Whether you want to continue doing this and go a bit more slowly, or you can complete this in your own time, and we'll go on and do more exciting things.
Hands up for going on to the new stuff.
Okay.
1, 2, 3, 4, 5, 6, 7, 8, 9. Well, we've got majority for going on to the new stuff, I think, already. But
Okay.
hands up, just to be sure, hands up for focusing on the exercise.
Join me.
1, 2,
Okay.
2
Well,
for the exercise.
I think we can say you
neutral.
can do this on Thursday, right?
Yeah, okay,
we can-
yeah, good idea. If anyone wants to carry on with it, then please come to the workshop on Thursday if you need help. Or
And
hang on back.
if you want to cheat, then the solutions or my solutions, they are on the website. This week 12 refers to a previous course, of course, but the solutions are online. So if you want to have a little bit of a hint, then the answers are there. But otherwise, if you come to the workshop on Thursdays, all right. Let's talk about resource management. So, really common pattern when we're doing pretty much any kind of programming is we'll acquire a resource, do some stuff with it, and then release it, right? And a resource here can be really anything, right? Some memory, we have a heap allocation, we go and ask the computer, ask the operating system for some memory, do something with it, free the memory, right? Or we can open a file, write to the file, close the file. Or perhaps it's a mutex, we can lock it, do something, unlock it, right? This is just a really, really common pattern for writing software. So it goes something like this. We have an acquire resource function, like malloc, say, open file. We do something with the resource, and then we release it. Like this might be free, for example. Right? Absolutely, really, really common pattern. There's a bit of a problem with this, though, in that it's really, really easy to get it wrong. And in garbage collected languages, at least for memory, garbage collected languages handle releasing memory for you, right? But that's the only kind of resource that they handle, right? Java doesn't go closing files behind the scenes for you, at least not unless you do clever things, right? So for C++, memory is just one kind of resource, but doing this manual management of it, acquiring, using, releasing, it's really easy to get yourself in a pickle because it's rarely as simple as this, right? Usually it's acquire, 3,000 lines of code, release. And in that 3,000 lines of code, there'll be multiple return statements, there'll be all sorts of things, different code paths, and you have to make sure that in every single code path, your release function, whatever it might be, freeing memory, closing files, unlocking the mutex, whatever it is, it has to happen exactly once. Because if we at least in terms of memory. If we never free the memory, that's a memory leak. That's really bad. Even worse is if we attempt to free the same block of memory twice, we're probably going to crash. Right? If we try that with a mutex, things are going to get even worse. Like deadlock. We try it with a file, well, you're going to run out of file handles and the operating system's going to kill you. Right? When you have this pattern, this release must be called, and it must be called exactly once. And getting this right is really, really, really hard in general. And it's particularly hard when you start using exceptions. So C++ allows you to throw exceptions pretty much everywhere. And if this do something function here were to throw, well, we're not in a try block or anything, so this would just exit from here, and it would never call release. So not only do you need to worry about multiple return statements, but you've got to start worrying about what functions could possibly throw exceptions, and you've got to wrap everything in try, and it gets really horrible. Right? This is really hard to get right, doing it this way. Fortunately, the C++ language gives us tools to help get this right. So we have constructors. Constructor is a special kind of member function that is used, it's called automatically when we're trying to construct an object. When we're creating a new object, it calls a constructor. As you can probably imagine, a destructor is the opposite. Destructor is a function that's called when an object is being destroyed. So by acquiring resources in a constructor and releasing them in a destructor, we can use the rules, the language rules, to manage this really difficult process for us. So now imagine we've got some struct that's a resource handle. So in the constructor of this struct, we acquire the resource, we open the file, we malloc the memory, whatever we do. And in its destructor, we do the opposite. We close the file or we free the memory. And now our example looks like this. We first of all acquire the resource by creating a resource handle object. Right, so the constructor acquires the resource. And then we do something with the resource, just exactly what we did before. And that's it. Because, if you remember, way back when, I was really, really banging on about value semantics and lifetimes and how the lifetime of objects in C++ is tied to their scope. So this is a local object defined within a function. So when we leave this function, this object will be destroyed. In fact, there is nothing you can do to stop it. Right? This object is gonna be destroyed. And that means it's gonna have its destructor called, no matter what. So if do something with executes perfectly and everything's fine, we're just going to fall off the end of the function. And when we hit this closing brace, all the local variables defined in the function, their lifetime ends, they get destroyed. And when things get destroyed, their destructors get called. When the destructor of a resource handle is called, it's going to release the resource. On the other hand, let's say something goes wrong and do something with throws an exception. Well, that's going to kick us out of the function straight away. But in C++, if we leave a function due to an exception, it still calls the destructors. It still destroys, calls the destructors of all your local objects. So even if do something with throws, we still get the cleanup. Right? This is brilliant. This is, like, I cannot emphasize just how good this is. And I've sort of underplayed it here. I say this plays a central role. This is not just a central role. I mean, this This is modern C++. This is the way we do things. And in fact, Rust, people who are into Rust, does exactly the same thing. Rust has taken this model and, in some ways even goes further with it. So this pattern, acquiring something in a constructor, releasing it in the destructor, and using a resource handle object that gets cleaned up for you when you leave the scope. This has a name. It goes by the acronym RAII, which stands for Resource Acquisition is Initialization, which is a stupid name for it, and even the guy who invented it agrees it's a stupid name for it. I think a better term is scope-based resource management, which is a bit wordier, but it at least conveys what it means. This means that when we leave this scope, the resource is released, no matter what.
Does that go up like?
Yeah, even if we've got nested scopes and all of that. It's the object lifetime rules in C++, when things come into being and when they're destroyed, these guarantee that our destructors will get run when we leave the scope in which the object was declared. And if the destructor releases a resource, then that gets freed. It's brilliant, right? Sorry?
Lion King, circular life.
Yeah, yeah. So this is why C++ has no garbage collector, because you don't need it. You've got this way of doing things, right? So, and this works not just for memory, as it does with garbage collected languages handle freeing memory for you, but this pattern works for files, for mutexes, for file descriptors, for any other kind of resource you might need to manage. And the standard libraries got some examples of this. So one example would be standard vector that you've all used already. So standard vector, when you call the constructor, if you place some things into it, it acquires some memory to hold those things. Right? You add more things to it, and then it goes and acquires some more memory to put more things in it. And you can carry on this process. And when the vector is destroyed, when it goes out of scope, it frees that memory, gives it back to the operating system. So you've already used a type that uses this pattern. You just probably weren't aware of what it was doing behind the scenes. But behind the scenes, vector is managing memory for you. Right, so if you were writing C, where we don't have destructors and you can't do this, you would manually have to go and call malloc and later call free and make sure you balance them all right. And it's a very horrible process of doing it.
Does that cover the heap handles?
Well, in this, so resource handle here is a stack object, right?
Yeah.
Typically it's very small, perhaps it just holds a pointer to some heap memory.
So if you did a new...
No, this pattern means you never have to call new.
Okay.
Right? This is, I can see people making notes. Write this in very big letters, right? Do not call new in modern C++. Since C++ 14, you should never call new. It's no longer needed. Because, in particular, we have this thing called a standard unique pointer that we're not going to talk about today, but we'll get to it in a few weeks' time. This, in particular, this is the thing that saves you from having to ever use new. Right? This manages, this is a handle for a heap allocated object.
So the bits in Bartrop's book that talks about new.
There are listed bits in
Bartrop's book, the C++ programming book.
Bartrop?
Bartrop is the
Straustrup.
Right. That's different.
Yeah.
Oh, is the book?
Sorry?
The new one, the programming principles and practice. Does he talk about new?
Well, probably haven't. It's a third edition or something.
Oh, right.
Downloaded. So he does talk about new in the copy I've got. So that's the don't look at that bit.
Well,
it's worth being aware of.
Yeah, it's one of those things, and I do this. I do this sometimes. I tell you, okay, this is how you do this, but don't ever do it.
Yeah.
And it's where I guess if you want to know the whole language, if you need to deal with legacy code, then yes, of course, you need to know what new and delete do. But it's always better to use a resource handle pattern like this than manually managing your own memory, because as I said, it's really, really, really hard to get right.
Sorry, very quickly.
Yeah.
So what's this resource handle?
So a resource handle, in this case, so I was just using generic terms, right? So like do something with, could be any operation, right? So if we go back to the, example here, I just had some imaginary functions called acquire resource and release resource.
Yeah.
So here, resource handle is some class, some struct that we've written, and in its constructor, it calls acquire resource, and in its destructor, it calls release. Right? So this is wrapping the resource management. It's a wrapper class that is a handle for whatever resource you might be using.
You implement your management logic in a class, and then once you've done it once, use it everywhere.
So, as I said, a constructor is a special kind of member function we use when creating a new object. And the job of a constructor is to make the object ready for use. So that includes acquiring resources, also setting setting values for any of its member variables, base classes as well. When you get to using base classes, it's got to prepare the object for use. And there are more uses for constructors, particularly constructors, than just resource management, but that's really the big selling point of them, right? So how do we write a constructor? Well, if you've used Java or C# or any of those sort of C++ derived languages, it's the same thing. We write a member function that has the same name as its enclosing class and no return type. So here we've got a struct example, and I've written a constructor. That is, it's a member function. In this case, takes one argument of type int and no return type. So this is how we write a constructor. The int I is just an example here. You can have constructors taking any parameter types you like. But this is what a constructor looks like.
I was wondering what you said in the comment you should get more before. I'm not writing down constructors.
It was just too long for the slide, that was all. So this is a common abbreviation for constructor. In fact, some people even say CTOR, which that actually takes as long to say as constructor. But anyway, the opposite of a constructor is a destructor, right? And this is automatically called when an object goes out of scope. Or, in fact, if we are foolishly doing manual memory management, if we call delete on an object, then it runs its destructor. Right, in particular for what are called automatic objects, that is local variables inside functions, normal objects, right? When we leave that function scope, when we leave the scope, that object is going to be destroyed, and it is guaranteed that the destructor is going to run. Right? No way around it, no way to avoid it. And in particular, C++ is very particular. The destructors are always objects are always destroyed in the opposite order to their created. So if we create objects A, B, and C, then they'll be destroyed in reverse order. So C, B, A. Sorry?
That's that.
That's that.
Stack, sorry, well, I've got my hands around.
Yeah, it's stack, yeah.
Well, it depends where you put when you create the object. The object might be on the stack, it might be on the heap.
Like a stack.
Like a stack, yes.
Oh, okay, yeah.
So the job of a destructor is basically to undo what the constructor did. In particular, releasing resources that the class uses. So how do we write a destructor? It looks a lot like a constructor, except it's got this tilde at the front, this squiggle. Right, this is like, what is it? It's a logical negation, isn't it? So you can think of it as negating a constructor, if you like. Destructors do not take arguments. Right? There is no other way to write a destructor. This is it. It never takes arguments, and you can never have more than one of them. Right? There is a destructor for a class, and that's it. What have I got? 6.5 minutes. Okay. Let's get on to, we'll just cover this, and that'll probably be it for the day. So calling constructors, creating objects. So far, we've written our own types, and we've used this curly brace initialization form, T, arg1, arg2, whatever. That's how we initialize things, right? We pass the arguments. We initialized each member in turn. So actually, we've been using sort of a special rule because our types have had no constructors. We're only just introducing them now. We've used a special rule that says, well, if you haven't got any constructors, we're going to let you just initialize the members in order. So that's actually what we've been doing. We've been using all the types we've written so far have been what are called aggregates. That is, it's just a sort of dumb collection of variables. Plain old data as it's known. So because the types we've been using so far meet this definition, we haven't used any private variables because we haven't discussed private variables yet. We haven't written any constructors ourselves because we're only just talking about constructors. We've been able to use this aggregate initialization. But if we do have constructors, if we do write a constructor, then doing this, the type, our type T, followed by the arguments in curly braces, that's going to try to call a matching constructor. I didn't mention this on the previous slide, but just like member functions, ordinary member functions, we can overload constructors. We usually, it's a very common thing to do, have multiple constructors, taking different argument types. Right? So if we use this curly brace form on a class that does have a constructor, it's going to try to call a matching function. It's going to use those horrible overload resolution rules that I discussed before to try and call a matching constructor. And if we do have a cut with a constructor, we can do the same thing, usually, by using round brackets as well. So this is this curly brace thing in C++ 98. This curly brace thing could only be used for aggregates, and for types with constructors, you had to use round brackets. C++ 11 changed it and let you use the curly braces to call constructors as well. So this form with the round brackets, it looks a bit more like a function call, right? It looks like we're actually calling a function because that's exactly what we are doing, right? This will call a constructor for type T, right? So it's going to be a function call. So it looks like a function call because it is a function call. Now, here's where things get a bit unfortunate. For the overwhelming majority of types, it doesn't matter whether you use the curly braces or the round brackets. The round brackets won't work for aggregates, so it's easy to say, oh, just use curly braces everywhere. But for a small number of types that try to be too clever, these do slightly different things. And one of those that you might run into is standard vector. So if we say this is kind of hard to see, isn't it? Also, my 3 looks like a closing curly, but anyway, you get the idea. If we say standard vector of ints, and we call it v1, and we use curly braces, and we put 1, 2, 3, that's going to create a vector containing the integers 1, 2, 3. Right? This is what we call a list initializer.
if we use the round bracket form instead, this is saying I don't want list initialization. I want you to call a constructor, and vector has multiple different constructors. I happen to know off the top of my head. There's one. This is going to create a vector that has 10 copies of the number 1. Right, so it's a vector of size 10 with all those 10 things initialized to 1. Right. If I change these to curly braces, now this is saying, okay, make me a vector of integers and fill it with 2 things, one with value 10, one with value 1. So this separation of a list initialization and constructor calling, it was a mistake, and now we're stuck with it. And
it's unfortunate, but it's something you kind of have to get used to.
It's a subtle and massive foot gun.
Yeah. The other problem, this bombshell that I will leave you with, is that sometimes, if we use the round bracket form, it's going to think we're trying to declare a function. So if I just write int I and some empty curly braces, this says I want you to initialize, to default initialize or value initialize, strictly speaking, a variable I. So it's going to initialize I to 0. If I write int j and then some empty round brackets, this is a function called j which returns an int and takes no parameters, right?
But that can only happen in global scope, right?
No.
As a horrible legacy of C, it is possible to declare, you can't define it, but you can declare a function at function scope. Yes. So if you write this inside a function, it will think you're declaring a function called j. This is horrible and insidious and evil, and I hate it, but it's one of the reasons that this curly brace thing was introduced in C++.
But that never made sense, right? I mean, you could never.
It kind of made sense in like 1970s C, where there weren't header files and you just called functions by luck, basically. Anyway, this at least like this, it looks like a function. If you just saw that code and didn't know anything about it, you go, okay, well that does sort of look like a function. Now that I look at it, right? This thing with the round brackets, it turns up in other places as well. You can unexpectedly have things that surprisingly get parsed as function definitions when you were intending to declare a variable. Function declaration, sorry, when you were intending to create a variable. It's so horrible that there's even a name for it. It's called the most vexing parse. And if you want to see some examples, just Google most vexing parse. There's even a Wikipedia page for it. Right, we're past time. So on that bombshell, as they used to say on Top Gear, I will leave you. Some say no. So thank you everybody for coming. We'll pick up talking about constructors and how we write them next week. And yes, as Tom likes to say, we're all off to the pub. So please do come and join us.
Before we go to the pub, just a quick update.
Tristan, could you just put the question back up? Is that possible?
Before we
Which?
disappear, I got some dates. So on the 15th,
This one.
this Thursday, we. Oh my goodness!
It's fine.
On 15th, we are here. Yes, in Skills Matter. So please RSVP if you want to join the workshop. On 20th, so next